methyl 1,3-butadiene. How about isomerism in alkenes? Yes, there is still isomerism in alkenes. To demonstrate, okay, why is this, okay, hindi pa rin ito. Constitutional isomerism. Saan ito constitutional isomerism? Same chemical formula, different connectivity. But actually, napa na siya butang niyo sa baba sa constitutional isomerism, napa na siya in two subtypes. Positional and skeletal. Mas better siya kung ako siya i-demonstrate rather than define lang. Okay? So, here, ayaw mo ka intimidate. These are just, kaning mga naka-blue, these are alkanes. Kaning mga naka-orange, these are alkenes. These are all the possible isomers of 4 carbon alkanes. Pila ka po, duha lang ang possible isomers. These are all the possible isomers for 4 carbon alkanes. C4 ba? C4. 4 carbon alkanes. 1 butene, 2 butene, 2 methyl propene. And the same here, the possible isomers for 5 carbon alkanes, possible isomers for 5 carbon alkenes. Class, what is positional isomerism? Sa positional isomerism, the structure, the skeletal structure of the carbon is the same. The difference is the position of the functional group. Positional isomerism. Pakita lang rin, I think mas better siya. 1 butene, 1, 2, 3, 4. 1 butene, so 3. 2 butene, 1, 2, 3, 4. 2 butene. Look at the skeleton. The carbon skeleton of these organic compounds. The same lang. 1, 2, 3, 4. Ano? Diba same lang? What's the difference? The position of the functional group. So that's positional isomerism. Positional isomerism. Pero pag mo yung tao, skeletal isomerism, this is not skeletal isomerism. Why? They have the same skeleton. The skeletal isomerism is kani 1 butene and 2 methyl propene. Ano man? 1, 2, 3. Double bond and branch. Tanaw ang skeleton. Take a look at the skeletal structure of this. Medyo weird pero na-direct. Take a look at the skeletal structure of this 2 methyl propene. Same siya or different? Different ang gamit na, di ba? Different, di ba? Different ang structure niya. So that is skeletal isomerism. Kani same lang siya structure, tanawan yung ana lang. Pero ang difference niya is position sa double bond. The position of the functional group. So these two are positional isomers. Pero ang difference na kani is the skeleton of the carbon itself. Kani kay ana. That's skeletal isomerism. So that means that for alkanes, paminaw ha, importante rin. The alkanes are only capable of skeletal isomerism. Why? Ngano din sila pala positional isomerism? Remember that alkanes do not have a functional group. So kung saan ito i-change yung position? Wala. So dili ta pwede mag-positional isomerism sa alkanes. So for alkanes, it's only skeletal isomerism. Okay, pwede ba natin i-change ang structure sa hydrocarbon itself. Nakuha? Everyone nakuha? Now positional isomers, structural isomers. Structural isomers. Positional isomers.
Skeletons or structural?
Ay, skeletal. Structural lang kung ginayon mo.
Yes.
Parang lang. Okay.
Typo.
Sorry. Yes. Okay. Now, di ba kanina sa mga cyclic na alkanes, cycloalkanes, we cannot rotate, di ba? Because of the rigidity of the structure. It's the same as double bonds. Tanaw, di na ko rotate. Since di na ko rotate, we still have the cis trans isomerism. So, simple lang din class. This is trans or cis?
Cis.
Different side.
Trans.
Nasa taas, nasa baba. Nasa baba, nasa taas. Trans. Okay, balik mo lang ko siya. Same
Cis.
side. This is cis. Isomerism. Simple din. Gets? So how to name? This is 1, 2, 3, 4. That's butane. Pero na double bond. So butene. 2 butene. Because that's the second carbon. But because they have, or they are on the same side. Asal same side, sir? Maski mo sa hydrogen, same side. Methyl, same side. This one is cis-2-butene. This one is trans-2-butene. And it will take chemical reaction to change cis to trans. So these are basically different compounds. Yes? Class, when you want to analyze whether cis or trans siya, you have to focus your eyes on the two carbons na nasa double bond. And then analyze kung asa ang mga nakakapit sa yahan. Same siya, cis. Different, trans. Kaya nga naman, naman yung mga complicated na structure that you have to analyze kung whether cis or trans siya. Anyway, just to drive home the point na different siya mga compounds, different po lang iyahang chemical and physical properties. And class, the way you write down na, mag-matter siya. For example, nani, both are 2-butene, pero same side din siya, so cis. Different side, trans. Koreano yun. O ayaw din mo ka intimidate. No. Ayaw hila. Pilitan sa 1, 2, 3, 4, 5, 6, 7. So heptane. Pero na yung double bond. So heptene. Ilang kapag double bond? 1, 2. So heptadiene. Heptadiene.
Duha ka double bond.
Ano, balik ko na ko ha. How many carbons? 1, 2, 3, 4, 5, 6, 7. Heptane.
Heptane.
Ilang ka double, na yung double bond? Wala. So heptene. Ilang ka double bonds? 1, 2. Heptadiene. Locate the double bonds. Carbon 2, carbon 4. So 2, 4, heptadiene. Carbon 1, 2, 4. 2, 4 heptadiene. Now, kanaman yung cis trans isomerism, tanawan ninyo, focus on the first double bond. Tanaw si hydrogen.
Trans.
Different side. Carbon, different side. So this is trans. The second, different side. Trans. So trans, 2, 4 heptadiene. Tama yun ang trans square. Malihan dito. Tama. Direct eh. Pakulan na lang. Organic chemistry. Pakulan siya. Okay. Sorry, organic chemists. Ano siya? Pinalagis ko yan. Okay. 1, 2, 3, 4, 5, 6, 7. Heptane. Double bond, heptene. Duha ka double bond, heptadiene. Position of the 2, 4. 2, 4 heptadiene. The 2, second na double bond, different side.
Trans.
Dire.
Same. Cis.
Trans, 2, 4 heptadiene. Plus, importante yung mag-ibalan yung cis o trans sa akin. I'll give you a, segue sa nakadali, sa biochem. Are you familiar with trans fat? Ano ko trans fat?
Nutritional.
Saturated fat. Unsaturated fat. So whenever you eat about unsaturated fat, we need to say that the fats contain double bonds. They are the healthier fats, unsaturated. The unhealthy ones are the saturated. Pero between unsaturated, kay unsaturated, di ba, nag-double bonds. So, na possible na cis o trans. Ang unhealthy na model would be the trans fat. Ano siya? Trans unsaturated fat. The healthier one would be the cis fat. Sige lang, okay, nadungog naman po siguro yung hydrogenation, di ba? Kano sa alam? Kanina, di ba?
Ganina. Unsaturated to saturated.
Yeah, turning your unsaturated to saturated hydrocarbon through hydrogenation. Kung makakita ka ng hydrogenated palm oil, that palm oil was previously unsaturated fat. Himo siyang saturated. Using what process? Hydrogenation. Nana siya sa ingredients, hydrogenated palm oil. Masarap po ninyo yung ikaunoy ng mga pagkaon. Nana dito sa ingredients. Okay, but not all, again, not all alkenes are capable of cis-trans isomerism. For example, what if two identical groups, puro siya hydrogen, sa isa ka side. Mas kinbalihon pa nato na siya, class. Isa pa. Okay, mas ikambyo pa nato na siya,
Hydrogen.
no difference.
To hydrogen.
There's no difference, mas i-change pa nato na siya. So we cannot really say cis or trans pag identical ang group sa one side. Use your common sense na good. Kung mo na siyang palihon, makugyapon, so hindi na mo siya mas-cis-trans. Okay, because they have two identical groups. How much more kung both sides have the same identical groups? Ano yun? Sige, balikan. Mas-cis-trans pa rin mo. Diba? Kuha.
Yes.
Physical properties the same as alkenes. Insoluble in water, soluble in nonpolar solvents, density is lower than water, so you mix alkenes with water, it floats. Melting point of an alkene is usually lower than that of the alkane with the same number of carbon atoms. So for example, if you want to compare the boiling points, melting points. If you want to compare the melting point of, let's say, propane and propene, mas lower ang melting point ni propene kaysa pang propane. Okay, same man sila. Same silang carbon atoms but they have different number of hydrogen atoms. So, mas lower ang melting point ni propene kaysa pang propane. Alkenes with 2 to 4 carbon atoms are gases at room temp. So, that includes ethene. Next kay ethene. Propene. Butene. Dire, unsubstituted alkenes with 5 to 17 carbon atoms and 1 double bond are liquids. So, kanang mga not including diene and triene, kanang mga isa lang ka-ene, pentene, hexene, octene, nonene, diene. Those are liquids at room temp. But those with more than 17 carbon atoms, those are solids. Oftentimes, ang tawag na ganyan sila wax. Paraffin wax, solid man na siya, di ba? Because that's a hydrocarbon that is very low. Okay, now let's talk about the chemical properties. So, combustion is still true for alkenes. There is still a production of carbon dioxide and, so ito, combustion,
Rapid oxidation.
rapid oxidation with the production of what? Two products. Carbon dioxide and water. Carbon dioxide and water. Okay, polymerization. Katong i-describe na ko kanina. Polymerization is just, mura ba, repeat, copy-paste, then i-connect mo tanan. So for example, vinyl chloride. If you have vinyl chloride, you connect it with another vinyl chloride, you connect it with another vinyl chloride. So on and so forth, tawag na is polymerization. Alkene molecules undergo an addition reaction with one another. And that is the creation of polymers. Anong plastic? Okay? For example, katulad niya, PVC. Okay? That's polymerization. Here we have addition. So there are 4 chemical reactions under sa addition. for the first two, addition of a symmetrical molecule. Kasi meaning sa symmetrical molecule, ang i-add nato is molecule that is diatomic. Symmetrical. Hydrogen, hydrogen. Dire, halogen, halogen. Okay? Symmetrical. While the other two is unsymmetrical molecule. Hydrogen pero halogen. Hydrogen may hydroxyl or water. Sige, let's start with the first two. Hydrogenation. Do I need to discuss pa rin? Nag-gets naman nyo ito kanina, di ba? Hydrogenation. Okay. So sa hydrogenation gas, we make use of hydrogen gas, add it with hydrogen gas added with special alkene. Alkene. And in the presence of the catalyst plus in the hydrogenation process, there is a catalyst. Kasi pasabutan ng catalyst, it is a substance that would speed up reaction. So nickel or platinum ang gamit ng catalyst. In the presence of nickel or catalyst, it becomes an alkene. So, ang may tabulan dyan na class is, i-break niya ang double bond, and then magputang lang ang hydrogen. That's hydrogenation process. Okay? So again ha, in hydrogenation, the product is alkane. Kung sa'yo gamit ang catalyst, nickel or platinum. Kung sa'yo i-add natin sa alkene, hydrogen gas. For halogenation, simple lang po siya. Mura lang siya hydrogenation, but instead of a hydrogen gas, it's a halogen gas. Okay? So for example, X, representing chloride gas, iodine, or bromide. Okay. Cut lang siya dira, ayun, ano siya? Dihaloalkane. Ano dihalo? Tuha ka?
Halogen.
Alkane. Nag-gets? Same lang siya. Same lang siya. Diri, hydrogen, diri, halogen. Gets? Kinatadrihan? So sa to, pag symmetrical ang iyan, molecule, we have hydrogenation and halogenation. Pag unsymmetrical, let's say, C double bond C, H, 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 H. We add, let's say, so may example ka sa hydrohalogen, hydrochloric acid. Hydrohalogen, hydrochloric acid. So yung nagtabuhan ng class. Makat lang na siya, it becomes the hydrogen here, butang siya dire. Ang chlorine, butang siya